Hello class, we are now in our second video in our video lecture series in Differential Calculus. Now in the first video, we were able to solve for the sample problems for the topic function. Now this time, we will solve for the sample problems in the topic limits. Now the lecture notes have already been uploaded in our MS Teams, so you just need to download it, and the theorem and the introduction for limits is already there. Now the purpose of this video is to solve for the sample problems presented in our lecture notes. So here we will solve the 5 sample problems, and we will start with number 1. Now we will be evaluating if these limits are existing. Now if not, we will try to use other methods in order to find out what method will the limit exist. So in number 1, we have there the limit of x squared plus 3x minus 5 as x approaches 4. Now here we will be using the substitution method. So here we will be using the substitution method. In substitution method, we will just replace x with the value of 4. So this becomes 4 squared plus 3 times 4 minus 5. That is equal to 16 plus 12 minus 5. And this is equal to 23. And yes, the limit does exist. Now, as we have mentioned in the first video, the first example will always be the easiest one, in order to have a hint on how we go along with the rest of the problems. Now, we will be solving for example number 2, and we will find out what other methods aside from the substitution method we could use. So for number 2, we have the limit of x squared minus 2 over x squared plus 2x minus 8 as x approaches 2. Again, we will be using the substitution method. So we will replace x with 2, and it becomes 2 squared minus 4 over 2 squared plus 2 times 2 minus 8. And this becomes 4 minus 4 over 4 plus 4 minus 8. And I'm seeing here 0 over 0, which means this is undefined, or the limit does not exist. So does this mean that we will stop here? Well, we will be using the other methods in order to find out if the limit exists using that method. So the second method we will use will be the approximation, the factoring method. So by factoring method. Okay? So in factoring method, we'll just factor out the numerator and the denominator. So what is the factor of x squared minus 4? That is x minus 2 times x plus 2. So if you multiply these two here, it will become this equation in the numerator. Then, for the denominator, we have x squared plus 2x minus 8. So, this is x minus 2, x plus 4. So that if we multiply this, we will have this same equation here. Okay? And as you can see, we can cancel out x minus 2 because they are similar. Yes, you can only cancel out similar terms. And what remains here is x plus 2 and x plus, or over x plus 4. The purpose of this is in order to avoid having the value of 0 over 0, just like here. Okay? So, using substitution method, we will replace x with 2. And the answer now becomes 4 over 6, or that is 2/3. Okay? Yes, the limit does exist. Now, what if I'm not good with factoring? What if I'm not that... I don't fancy using the factoring method. Well, we have another method that you could try, the approximate method or the approximation method. What do we mean by the approximate method? As you have observed, when we use the value of 2 in substituting for x, we arrive at the answer 0 over 0, right? In the substitution method. Now, in order to avoid that, instead of using x equals to 2, we will try a number that is near to the value of 2. Well, as you have observed, it says here x approaches 2, not x equals 2. So that means we can use other number that approaches 2. So let's try 1.9999. Well, you can use 1.99 or 1.999 if that is more convenient for you. But for me, I've been using 1.999 or 4 decimal places always for a more precise answer. So here we will be using 1.999 to substitute for the value of x. So we have there 1.9999 squared minus 4 over 1 all over 1.9999 squared plus 2 times 1.9999 minus 8. So using your calculator, what is the value for this one? So 1.9999 squared minus 4 over 1.999 squared plus 2 times 1.999 minus 8. So the answer for this is 0.667. So again, the value still exists. Is this similar with 2/3? What is 2 divided by 3? Well, it's 0.6667. So, similar. Yes, you can use whatever method that is fitting for you or you find more easier. You can have the substitution method, factoring method, or the approximate method, because we will be having the same answer. Aside from this one, it has 0, 0. In case you get a number of 0, 0 here, the value of 0, 0, apply the approximate method. Okay? So that is for your example number 2. Again, whatever method you use, either factoring or approximate, as long as the value here is 0 over 0 and still acceptable. Okay? Let's go for example number 3. For example number 3, we have the limit of sine 3 theta over theta as theta approaches 0. So how do we solve this kind of problem? Well, we will be trying to solve for or using the method of substitution by substitution method. Now, a word of caution here, since we are under trigonometric now, note, simple note, you have to set your calculators in radian mode. Okay, yes. Set your calculators in radian mode. So what happens? You substitute here the value of theta with 0. We have here sine 3 times 0. So we have there 0. What happens here is this becomes what? This becomes undefined. Or the limit does not exist. So if we encounter this again, we will use other methods. Now we can use the method of theorem 4. So we have there by theorem 4 method. What's with the theorem 4 here? Is the theorem 4? In your notes, it states there, theorem 4 is limit of sine alpha over alpha as alpha approaches 0 is equal to 1. Now, since the problem is tackling sine, so we will choose, under theorem 4, we will choose then sine also. So, sine, then also sine. To use this theorem, we need to set the angle for sine. So, see here, the angle alpha. So, sine alpha, which should be similar with the denominator here, alpha. Now, is that the case with our problem? No. In our problem, we have there 3 theta or sine 3 theta over theta as theta approaches 0. Well, it's good that this one here is the same. But what is not the same is the angle is 3 theta while the denominator is only theta. So we need to make them similar. How? We will be able, we should put here 3 so that they are similar. But we need to put here 3 also so that we can cancel this one out and then go back to the original equation, which is limit of sine 3 theta over theta. So to balance the equation, you put 3 here in the denominator and 3 also in the numerator. So as you can see, they are now similar. 3 theta, 3 theta. Now we can now use your theorem 4. So what happens? Using theorem 4, this becomes 3 times 1. Why? Because limit of sine 3 theta over 3 theta as theta approaches 0 is 1. So the answer here is 3. Yes, the limit exists using theorem 4 method. Now, do we have to memorize all theorem 4? Or what if I forgot that there needs to be a similar angle in the numerator and the denominator? Well, we have another method to use. We will be using here your approximate method by approximation or approximate method. So by approximate method, you have observed here that theta approaches 0, but when you substitute there 0 for theta, the answer becomes undefined. So in order to avoid the undefined answer, instead of setting theta to 0, we will look for a number that is almost or that is near to the 0. So we can try 0.0001, or still that is 0, right? So let's try 0.0001 instead of just 0. So let's substitute theta with 0.0001. So this becomes sine 3 times 0.0001 over 0.0001. So using your calculator in radian mode, I repeat, that should be in radian mode. We have there sine 3 times 0.0001. So the calculator, in your calculator, it looks like this. The double parenthesis 0.0001. So the reason why you should put your double parenthesis here is because if it's only single parenthesis, the answer is syntax error. Okay? So the answer for this is 2.9999, or that is 3. Similar. Okay? So there's 3 methods that has been used for number 3. By substitution method, well, you got an undefined answer. So we can use either theorem 4 or the approximate method in order to get the answer. Okay? Next, we go to example number 4. In example number 4, we have the limit of 1 minus cosine y over sine y squared as y approaches 0. Now, how can we solve this? First one is by substitution method. So by substitution method, we just substitute the value of y with 0. And again, you have to take note that in solving this problem, you have to set your calculators in radian mode because we are dealing with trigonometric. Okay? So we have there 1 minus cosine of 0 over sine 0 squared. That's how you type in your calculator. So 1 minus cosine 0 over the parenthesis sine 0 parenthesis squared. Oh, it's math error. It's math error because the answer here is 0 over 0. Why? What is cosine of 0? Cosine of 0 is 1. So this is 1 minus 1 over 0, 0 over 0. And that is undefined, or the limit does not exist. So what other method are we going to use? So let's try to use your factoring method. By factoring method, we will factor out the original equation. What's the factor for numerator? None. 1 minus cosine y, still cosine. How about sine squared or sine squared y or sine y squared? Is this familiar? Yes. This is your Pythagorean theorem. So what is in Pythagorean theorem? In Pythagorean theorem, we have there, okay, sine squared x, or in this example we are using y, plus cosine squared y equals to 1. Therefore, sine squared y is equal to 1 minus cosine squared y. So this sine y here becomes 1 minus cosine squared y. Again, what happens here? 1 minus cosine squared y. Can we factor this one out? This is similar with 1 minus x squared. Right? So this is 1 minus x squared, and the factor for this is 1 minus x 1 plus x. So that if you multiply this distributive property or whatever, you will still arrive with 1 minus x squared. Therefore, the expanded form for this is 1 minus cosine y 1 plus cosine y. So we can cancel these two here, the numerator and the denominator, because they are the same. So what is left? What's left here is 1 over 1 plus cosine y. So can we now evaluate the limit? The limit of y, the limit of 1 over 1 plus cosine y as y approaches 0. Substitute the value of y with 0. So you have there 1 over 1 plus cosine 0. So again, your calculator should be in radian mode. So this becomes 1 plus 1. So 1 half. So the answer here is 1 half. The limit does exist. is that the only method we are going to use? Or are there other? We can try approximate method, because in case that you forgot what is the Pythagorean theorem, so you can go to the other method, the approximate method. Again, the reason why we are using approximation is that when we use y approaches 0 or y equals to 0, the value becomes 0 over 0, or that is undefined. So instead of using 0 for y, we will try a value that is near 0, and that is 0.0001. So we substitute that to the original equation. The original equation of 1 minus cosine of y, or 1 minus cosine 0.001 over, in your calculator you have to use parentheses, so there, the original, sine of 0.0001 squared. The way I'm writing here in our solution is what it should look like in your calculator. By the way, I'm using Casio calculator here. If you're using other calculator, well, I don't know how does it look like. But if you're using Casio calculator, you should punch in the same your parentheses that way, so that you will be able to arrive to your answer. So what is 1 minus cosine 0.001? Again, we are in radian mode, over parentheses sine 0.001 squared. The answer here is 0.5, and that is similar with this one. So again, you can use either the factoring method or the approximate method. Right? That's for your number 4. Now for our last example, that is number 5. Oops. For number 5, we have the limit of sine squared theta over tangent theta cubed as theta approaches pi over 4. So what can we use here? By substitution method, you have to take note that we are using radian mode. So by substitution method, you are to input into your calculator parenthesis sine pi over 4, another parenthesis for the squared, over parenthesis tangent pi over 4, then cube. Then, what's the answer for this? So sine, so parenthesis sine, shift pi 4, parenthesis squared, parenthesis tangent pi over 4, parenthesis raised to 3. And the answer is 1/2. The limit does exist. So that's how it is. We were able to we were able to use other methods in solving for limits. Try to solve for the sample problems presented in your reference book or the exercises presented in your reference book, and you might be able to, if ever you'll be able to find other methods to solve for limits, might as well share it with the class so that everyone will benefit. So this ends our lecture for limits today. Stay tuned for the